in this quarter, starting quarter 4, it is quite a long quarter. So we have separated the quarter into 2 parts with 2 big topics. So in this video, I will be talking about the first part of the quarter, which is all about logarithmic functions, on its origins, how to find them, the rules, and how we apply them to real life according to my big project. Just before getting our hands into logarithmic functions, we must know how to transform the functions no matter what type they are. We learn to either move it around horizontally and vertically, squeeze it and compress it in terms of either the y or x-axis, or reflect it as well. As you can see, each of the transformations have different rules which we can apply to the function to be able to interpret in terms of the function we want, as I did show in the document above. For example, in real life, the function of a project is at a negative point. In reality, that cannot happen. Therefore, we have to transform the function by moving it horizontally away from a negative point, in which we have to apply a rule we've learned. Exponential functions are what we have learned since approximately on High School Math 1. In fact, logarithms are the inverse functions of exponential functions. Oh my god, how amazing! Getting a step closer to logarithms, we learn about the inverse functions. For a function to be an inverse, we have to prove it by doing the horizontal line test. If the line crosses the function more than once, therefore, it is not one-to-one function, meaning that the function does not have an inverse. In terms of finding the inverse with the use of equations and algebra, a knowledge which we must acquire in order to receive an understanding of logarithmic functions is that we can use x in terms of y and follow the steps at which we solve for y to find the inverse. So, right before getting to the uses of logarithms, we must know the rules in order to apply them into equations in certain practices or even real-life problems involving exponential growth. There are many logarithmic rules we need to know, as shown here in this slideshow, which consists of adding exponentially, or either like multiplying exponentially, subtracting exponentially. In real life, logarithmic functions are very useful. Especially, I will show it here how I apply it to my big project for the quarter, part 1. Starting off with my data, this shows an exponential growth of the bean sprouts I've planted with 3 different liquids. To apply to the standards we are learning, I want to find out how much time it will take in days for my bean sprouts to grow into a desired height of 1 foot, or approximately 30 centimeters. To do that, I use on what I have learned from the topic of inverse functions to do so. I convert the exponential growth function in terms of sprouts heights from what I have interpreted from GeoGebra into terms of the variable t for time using logarithmic functions to do so. Many of us would ask, why would we have to learn math? So, in this part of the standard of the quarter, which involves logarithms, this standard applies to involve converting a certain function into many shapes, in which we only change in terms of the constant which determines what it looks like on the graph. When we are able to transform functions into many formats, we can look for certain solutions based on real-life problems, which can further be converted to logarithmic and exponential functions, which we are particularly the inverse of another, a standard we focus afterwards, which I'll explain later. In terms of the big project, we find out how many outcomes from function transformations in terms of adapting into logarithmic and trigonometric functions, but will be in the part 2 of the quarter. In terms of the function having an inverse of one another, we're able to know how an inverse of a given function can be used to solve problems in real life. According to the first phase of the BRIC project, which is particularly based on logarithmic functions as so, it is an inverse of what we've learned in the beginning of the year, which is exponential functions. Since exponential functions are really common in reality in terms of biology, business, engineering, and a lot more, to make our lives easier, we want our function to find in the opposite trend, which is logarithmic functions. Applying to the big project again, I'm measuring the growth rate of the bean sprout tested on 3 different liquids. The exponential function can determine the growth rate, only the growth rate, but we want to determine the amount of time, so that is what we need to know. So, this could also be applied to many fields other than biology or botany as I was doing. So it could be predicting populations in the future, investment trends, medicine activeness, and many more.